So BTDA, we discussed, obviously it's a solid. The monoanhydrides, for the most part, are liquid systems. So what can we say about improving the use of BTDA, the introduction of BTDA into your system, the processability within an epoxy system? What are some of the things that work with regards to perhaps looking at blended systems, for example, to kind of alleviate some of the concerns that that people have about introducing a solid particle into a liquid system?
I think that's where the blended systems really shine. The whole concept of being able to use a co-curative that is low viscosity, that helps thin the epoxy. It allows incorporation of the solid particle into the resin much more effectively. I mean, we saw this with syntactic foams, where you would make an epoxy system, and we were able to load it quite highly with the micro balloons, upwards of 20-25 volume percent, and the resin itself was stable enough. There was no sedimentation of glass beads,
creaming
particles.
Creaming up of them.
Yeah, exactly.
Yeah.
Everything,
so you're able to
stable.
drive some of the properties just with this blended system. And by blended system, what are we talking about? We're talking about BTDA with a specific monoanhydride or a selection of different ones? Or
it was the NMA native methyl anhydride.
was probably the best one.
Which was nicely mated, I remember, yeah.
They were a great combination, and with the right accelerator, you got the cure to occur at a lower temperature than you might have needed or been able to obtain given the equipment that was being used.
I mean, there's no reason why we couldn't introduce other monoanhydrides and make similar type of blends, but I remember even from a viscosity standpoint of the methyl, it was a very nice match. Simple, stable, pourable paste.
And we specifically chose that particular monoanhydride because it by itself would give the highest TG of all the highest glass transition temperature of all the monoanhydrides we had at our disposal. So, so it was the best option from that perspective as well.
Totally over the top. And we've seen a little bit from the accelerator side also some differences in terms of how a blended system behaves. It's hard to make generalities. In order to get the most out of these type of systems, you've really got to start matching components very well.
It depends on which anhydride is there in the highest concentration. The monoanhydrides, the dianhydrides seem to prefer different accelerators. Quite surprisingly, you get very different results depending on which system is chosen. Some will induce homopolymerization as opposed to getting the true cross-linking reaction you want.
So that match has got to be right.
But
the fun thing is, now we can take a simple DGEBA resin, add a blended curative system, and now we're driving TG over 200 degrees C every day.
Exactly, and without having to resort to more exotic A-side components.
That's right. So it's kind of this missing link that people have been looking for in terms of how do I retain epoxy performance, how do I drive my properties, how do I get over 200 C comfortably, and not look at exotic chemistries as an alternative.
I think there's enough knowledge base at this point to know where to start in terms of what ratios of different anhydrides to use. I think the part that still needs development and will work forward is identification of the right accelerator systems that match most effectively with both systems.
Which of course will also depend upon the application process. But those solutions can be found.
Yes,
absolutely.
With the tools we have.
Right.
And it's the same thing. You got to break through the preconceived notions and start looking at some novel combinations, and all of a sudden you've got exactly what you're looking for.
Yeah.